What's up, guys? Welcome back to another live stream from Scalar Learning. And today we are back to doing SAT math straight from the store, straight from Khan Academy. And as you can see, we are continuing today with solving complex number problems, excuse me. All right, so we got it queued up. I got the calculator in case we need it. And we're going to tackle 5 problems. Here we go. Haven't seen these problems, looking at them for the first time. This is not timed, so we're just going to roll with it. Let me make sure I did hopefully I chose the right circle equations. Yeah, we're good. Beautiful. Pick the right topic. Okay, here we go. Let's begin. Which of the following is equivalent to the complex numbers shown above? Okay, so what I'm going to do here is we've got to sort of slowly break this down. I actually already see a good thing a way that I can do this. Now we could just straight up square this, like foil it, and then foil the product of that with the last one. That would be all right, and we'd get the right answer. I'm noticing that we've got a special situation here that might make it faster. So I see this. I see a minus and a plus. This is no calculator, by the way. I see a minus and a plus, and that's really good to me. Hold on, let me just see. And so the reason why that's good is because if I foil this first, I'm just going to get a binomial instead of a trinomial. So watch. So we go 8 times 8. This doesn't matter, like I said, if you don't see this. 64 plus 16i minus 16i. And then that's minus 4i squared. So this cancels out 69 minus 69. This becomes 64 minus I squared is negative 1. So it's like kind of like plus 4. And now we got 68. Not even a binomial, sorry, excuse me, just a single term. So look how much easier this is now. Now we have 68 times 8 minus 2i. Literally just distribute. And this becomes 480 plus 64. 544 minus 136i. I think that's the answer. Wait, but I didn't see that. Hold on. Okay, there we go. 544 minus 136i. I think that should be it, unless I made a mistake, and I didn't. All right, good. Next. All right, we've got square root. So what's the following equivalent? So again, I'm going to use my simplification rules. Oh, now this is really important. So I've got I to the 41st, and here I've got 27 I to the 101. So I can actually drastically simplify these. Now here's the rule with I. I squared is negative 1. I equals, I. I cubed equals negative I squared, basically I squared times I. And then I to the 4th equals positive 1, right? So we've got all this. So now what's I to the 41? Well, anything that's going to be divisible by 4, I to the 4th, I to the 8th, I to the 16th, they're all going to equal 1. I to the 40th is divisible by 4, so that equals 1. I to the 41st then is just I. Okay? So now we can simplify this as square root of 54 times I over square root of 27. And this is also 100 is divisible by 4, so to the 100th power is the same as 1. 101 is like I to the 1st, which is just, again, I. So look, these i's cancel out. Then I can re-look at this as one giant square root. I don't have to separate them. I can kind of keep them like this. 54 divided by 27 is just 2, and that should be the final answer. All right, excelentes. Nextos. Okay. 2 times 2 minus I minus 2 times 2 plus I. Equivalent. All right, so the key with this is we got to combine these. So the way we're going to combine them is I'm going to multiply this by 2 plus I, and it's 2 plus I, 2 minus I, 2 minus I. Okay, oops. I'm just trying to make this a little nicer. Random number calling me. Okay, then we're going to have common denominators now because I have 2 plus I, 2 minus I, 2 plus I, 2 minus I. Let's distribute here. So then it's all going to be over one thing, 2 plus I times 2 minus I. This becomes, distribute, 4 plus 2i. And don't forget the minus tags everything. This becomes minus 4. And that would be negative 2i, but the minus there distributes and makes it plus 2i. Okay, these 4's cancel out, and then I have 2i plus 2i, which is 4i. So now I have 4i over, let's go ahead and multiply this out. Foil it. So I have 4 minus 2i plus 2i minus I squared. These cancel out here, right? Opposites. And then I have 4i over 4 minus I squared. I squared is negative 1, so it's like 4 minus negative 1, which is a plus. So then I have 4i over 5 right there. Just look at the other ones just for fun. I think that's right. As long as I didn't make any mistakes. Yeah. All right, good. Next, which of the following is equivalent? Similar deal. Immediately when I see division of something like this with these little polynomials, I'm going to turn that into multiplication by doing keep, change, flip. So I keep the first one, change to multiplication, and then flip it. It becomes 1 plus 2i over 1 minus 2i. And then I'm just going to FOIL. Wait, hold on. Let me see how they list these. It's definitely not A or B. I guess it's one of these two. So let's FOIL it and let's see what happens. So this. Everybody's calling. All right. All right, sorry. So then I multiply across by foiling. Boom, boom. Right? So on the top I have 1 plus 2i plus 2i plus 4i squared. Over, let's FOIL this. 1 minus 2i, right? 1 minus 2i minus 2i minus 4i squared. Okay, let's see what this reduces to. This is 1 plus 4i on top. And then 4i squared is just negative 4 over 1 minus 4i. 4i squared is negative 4 minus that is plus 4. Okay. Then 1 minus 4 on top is negative 3 plus 4i. And then that becomes 1 and 4 is 5 minus 4i. This is weird. Because how did they get... Wait a minute. So I did something wrong. 1 plus... It's that over that. And then that multiplies that. That multiplies that. Hold on. Something is off here. Because I don't see how we would get one of these. Because we got to get it over 25. 5. How do we turn that denominator into 25? Negative 3 plus 4i. Hold on. Did I do something wrong? Let me double check. 1 plus 2i plus 2i, 4i. And then minus 4. So it's like negative. And then this is 1 plus 4i. Oh. I did do something wrong. All right, that's it. That was supposed to be plus 4i squared. You see negative 2 times negative 2 is positive 4i squared. So that's minus. Oh, maybe I'm wrong. Maybe it was one of the first ones. So then I have negative 3 plus 4i on the top. And I also have negative 3 minus 4i on the bottom. And then... No. Still is not right because... Plus 4i minus 4i. Hold on, we break this up into two different ones. Ooh, I'm kind of confused. That almost looked like it was going to be 1, or negative 1 actually. but it's not because, oh, hold on a second. Wait, can I just simplify this really quickly? They're opposites. No, I can't say it's 1 or -1, because it would be like if it was the same thing divided by itself, then I would say it's 1, but it's not. And then it's like something divided by its reciprocal, so it would be like 4/3 divided by 3/4, which is 4/3 times 4/3, which is 16/9. That's not 1 or -1. So that doesn't make any sense. Like I said, it's got to be one of these bottom two, but let me just double check my work one more time. Okay. 1, 2i, 2i, 4i squared. That's -4, 4i, and 1. Then I got 1, -2i, -2i, -4i, and then plus 4i squared, which is -4. And then we get this. Okay, I know we're close. So then, how did they get that over 25? Okay, let's see. So then they split it up into the imaginary and real part. Oh, I bet you I know what they did. I know what they did. They don't want the imaginary in the bottom. So then they multiplies times -3 plus 4i. -3. I bet you this is it. -3 plus 4i. Okay, forgot. I totally was blanking on that. They don't want, in the SAT, usually in these final answers, to have I on the bottom. So now, let's FOIL the bottom. The bottom is going to be simple. It's going to be 9 minus 12i plus 12i, so those cancel out. And then minus 16i squared. Boom, those go away. So this becomes 9 and 16i, there's our 25, right? 16i squared is -16 with a negative in front, so it's positive 16 on the bottom. And then this becomes 9, minus 12i plus 16i squared on the top. So that becomes, this again becomes -16. So 9 and -16 is -7. -7 minus 24i. And then I can break this up as -7 minus 24i over 25. Minus 24i. It's D. That is the disconnect. Okay, so that even took me a while, and I'm sure on a real test that would have burned a lot of time. But that you got to remember that they don't like radicals, or I is usually in the denominator. And so once you make that connection, how do we get rid of the denominator multiplied by the complex conjugate? Let me think if there's an easier way to do this one. I'm pretty sure. Let's check make sure it's right first. Yeah. All right. It's correct. I don't know of an easier way off the top of my head. Yeah, I can't think of one. So I think you just got to roll that way. Let's see what they did. Yeah. Yeah, see, they got the same thing we did. Yep. And then they rationalized the denominator. Or not rationalized it, they took the imaginary part out. So that's it. Boom. That was really hard for an I've never seen a complex number that hard. That was pretty hard. Now, this is beautiful. All right, remember what I told you before. I is I squared is -1. I cubed is -I. You should probably memorize this maybe, and that's 1. So look, it's I cubed, which is -I, and I squared is -1. That's it. Which of the following is equivalent? -I minus 1, or they did -1 minus I, same thing. Okay, boom, and it's correct. All right, so that is it. Just see if we have any questions. Hey, what's up? I don't know. I assume you're applauding that last problem that had me thrown off for a second. But thanks, Victor. All right, guys, thank you so much for watching. If you like this video, please click the like button. It super helps out this channel grow and spread the word to help more people conquer and master SAT math. Thank you guys so much for joining. Also, if you have additional questions on any of the problems I solved, make sure to leave your questions in the comments section below. Thank you so much, and I'll see you guys next time. Take it easy.